Hello, welcome and good morning to my CIP presentations. A few words about myself. I'm Oliver Meinhold, originally from Germany. I'm a brewing scientist. I moved to the States about 15 years ago, worked for Loeffler Chemicals. Now I'm working for Zee Loeffler. Our main part is the cleaning and sanitation program for the brewing industry, wine industry, and also the distilleries. And today I will talk about the cornerstone of hygienic production in modern brewing and distilling operations. First, let's look, what are we talking about? This is a picture of a calendaria, which is like an internal boiling device. You can see, you have all the tubes, which are surrounded by steam, and basically they heat up the mash and the wort. If you see such a fouling on it, that clearly indicates that it's time to clean it. Normally it should be nice and shiny stainless steel. Especially in this case, when it starts growing more and more, the tubes will be blocked, and then your heating will be more difficult, and you will have more and more intense fouling. Another typical situation is a fermenter after it's emptied. You can see a dotted line, everything below where it's fairly clean. It's the liquid surface. You can see above the famous Krausen ring. You can see that in the center, your spraying device, a rotary jet, was also submerged in this foam head of the fermentation. And this is also very important to check if you run a CIP or prior to the CIP that your spraying device is fully functioning. Otherwise, your cleaning result will not be as intended. So make sure when you start cleaning it that your spraying device is properly working. When we talk about the whole process and what kind of material is going to be in your systems, what needs to be cleaned, I put up two examples. One is basically the malting barley and malt. What kind of compounds are actually discussing? And if you look at this table, you can see there's two major compounds. One is like over 60%, around 60% it's starch. So we talk about an organic substance. And then if you go a little bit to the center where we talk about proteins, that's around 8 to 11%. Everything else is fairly low, but that tells you that primarily during the hot time, in the kettle, in the mash tun, you will have fouling and starch from the starch and the proteins. And if you really burn it heavily, scorching. Another compound is the water. These are typical waters out of the brewing industry, but in general, it's just to explain to you that depending on the amount of hardness of your water, you also have to, get a higher likeliness of building up a scale in your equipment. If you look at some of these waters like far right, Burton or Dortmund, these are famous for very, very hard waters. So you have a lot of calcium and magnesium in these waters. And they tend to, precipitate out and then get building a scale on your surface of your equipment. So then you look at the other compounds you will put into your process later on. This is the approach, what actually material we are facing, how that determines later on my cleaning result or my cleaning procedures. Just looking at the process, we have in the far left corner, we start with malting. Then we have the brew house where, we prepare the sugary solution in quotation marks, which will be then fermented. This is kind of similar to the brewing industry in the distilling industry. Of course, in the distilling industry, we are focusing more on, especially high yield on alcohol, the more the better quotation marks. So once the fermentation is done, we have the wash, and then we basically go, and this is just an example. It's not like for everybody the same. Everybody has a little bit of a different setup, similar to breweries. You have 1 or 2 distillations, then be collected, then some will be put in different type of oak barrels for aging. Then we filter them. Some of the stuff gets stabilized depending what kind of material is used for this. Another few filter steps until it actually ends up in a storage tank and then finally being packaged in a bottle. So we have all kinds of different equipments in between, from, starting at the malt down to the finished product in a bottle. And all these different parts or process steps needs to be cleaned. And like I said before, just picture what are you putting in, what do you have in there, and what needs to be removed and how needs to be removed. So let's look at the terminology. CIP stands for cleaning in place. It's basically a method where we don't have to disassemble the equipment. It can be used as is with maybe some minor changes. It's often used for internal cleaning. So you have all your pipes, your heat exchanger, your different vessels, your fermenters, and so on, your storage tanks. All these will be cleaned by an automatic system. Like I said, it's no major modifications required. A pump will basically take the cleaning solution out of a storage tank, circulates it through these equipment, through a spray ball, through rotary jets, etc., and brings it back to the storage tank, and that is basically the cleaning. The advantage of a CIP is that it is very consistent because you always have the same time, you always have the same pressure, you always have the same chemical in there, which makes it more economical. It's not like one time you use more, one time you use less water or chemistry. And due to the fact that it's completely enclosed and very automated, highly automated, it's very safe for the people working there. Typical samples of CIP systems, let's say in the bottom right corner, that's more a smaller skid, which you find often in smaller facilities. It has 3 tanks with one pump, so it can circulate one chemical at a time, caustic and acid, water, and so on and on. Very common system throughout the craft brewing industry, although in smaller distilleries. Whereas on the left side, in the colored version, you have already 3 lines, so you can run actually 3 CIP systems independently, parallel, and no matter what kind of chemical you're using, the one tank might get a caustic application, the other one might get already an acid application, and so on. And in the middle, the picture is showing you a valve block, which is basically the controlling unit for all the liquids going the right direction from the right tank to the right tank to be cleaned. Some of these larger facilities, they have huge valve blocks, with hundreds of these valves because they are so highly automated and can do so many, cycles at the same time. The opposite of CIP is COP, cleaning out of place. That basically means you have to apply much more mechanical work. You have to break down the equipment. You have to take them apart. You soak them in a bucket. You take a brush, you take a sponge, whatever, to kind of wash them, to clean them. You soak them again. Sometimes it is even recommended, if you have like a tank with a CIP, fully CIP system, that a sample valve should be taken off, taken apart, and basically soaked and manually cleaned. But this is only here and there to do it, just to ensure that it's always cleaned. It's a visual inspection. Second, you will do a more intense cleaning. But overall, the more automation, the less COP, the better it is. Although very problematic is everybody has a different feeling of cleaning, so it's a high inconsistency. Taking things apart, soaking them, putting them back together, it's very time consuming. And of course, I always ask people to wear all the proper PPE. The exposure hazard to the chemicals is also a big issue. 2 old examples of a COP. The left person is standing in a horizontal tank where you basically clean by manual. You bring in a hose, you bring in a scrubber, and so on, and you clean everything out. I still remember doing this in a brewery in Munich, that we kind of pre-cleaned the tank before the actual CIP started, and although we had to push out the yeast first, which was collected, so we always had to put on some special fully sanitized boots before we were able to go in there. The right picture is a very common lauder tun where somebody walks in. It's nowadays OSHA would probably get a heart attack because of the danger. If you do everything in such things, always make sure you have your confined space entry permit, and you did all the lag out, talk out for all the equipment, so nothing can happen, and always have somebody outside, who can help you in case of an issue. So what's the theory behind the cleaning? Cleaning sounds simple. Everybody cleans at home, if it's the laundry, if it's the dishes, and so on, if you just sweep the floor. But so we have basically 4 steps. First, what we do, we bring the cleaning solution to the point of use. So let's say in your fermenter, the picture I showed you at the beginning, So you bring your caustic to that point, and first what you do is basically you wetten the whole surface and the whole soil of your krausen ring or whatever the soil is. Then with the chemicals inside of the solution, of course, they will start reacting. And so we have various processes going on. Make sure if you have your caustic solution, try to use kind of softened water. The harder the water it gets, the more the hardness of the water competes with the soil. So the caustic is not really focusing on the soil, it also focuses on the hardness. Good built chemicals nowadays have, good chelating agents in there, which takes care of this. Then we have the, through convective and diffusive transport, the cleaning agents get deeper into the soil to ensure that everything gets properly attacked. Once that is done, you will see a chemical and physically. Physically is either from the heat, from a hot caustic, or, if you have a spraying device where you have a lot of impingements, so you will get actually more activity inside the soil. And then you will start actually loosening it up. So you broke down various bondages inside of the soil to make it in small particles, and then it can be removed. So we have multiple terminologies like, dispersion, saponification, emulsification, and others. So dispersion is basically that all these tiny particles will be evenly distributed in your liquid. So in other words, you put them into your liquid after they've been loosened up, and you can move them away. Saponification is basically a chemical reaction when you have fat or oil, and it reacts with your, strong caustic or base, and that gets you a soapy feeling. That is like when you get a drop of caustic on your fingers. I'm sure you experienced this already. You get this kind of soapiness on your finger. That is actually nothing else, because you have a fat and oily film on your skin, and once the caustic gets on there, a saponification takes place. Emulsification is another thing which happens quite often. That is when you have the chance to bring two liquids together which don't like each other, in quotation marks, like oil and water. They will separate, but with the help of other ingredients, you can emulsify it and basically bring then the oil in small particles, and then they can be removed. Important is, with your CIP system, once you have everything dissolved, everything is now in the liquid, that you go back to your CIP tank and make sure that everything which was loosened up and is in the liquid doesn't redeposit someplace else, and basically you just carry the soil from A to B instead of going to the CIP tank. Make sure your CIP system itself has like a strainer before it goes back into your collection tank to avoid that you will basically contaminate your caustic too much. But this is, the theory about how to remove soil from the surface. We have basically 4 parameters, what we call the operational parameters. There's the chemistry, then we have the mechanical energy, from the pump with the water going through a spray ball and so on. Then, of course, temperature, and at the end, the time. And then you add those up. The sum of all these 4 parameters create like a cleaning result, and the more automated the system is, where you keep the chemistry always in the same concentration, you always have the same pressure on your pump, the time is always the same, and so on, you will have a very constant cleaning result. And of course, depending on your system, you can always make sure that the cleaning result gets always optimized. Just to kind of picture a little bit, so we have here basically the adhesive forces. So you see the bottom lighter colored blue is the tank wall. Then you have the soil sitting on the tank wall, and the soil is attached to the tank wall with various forces, adhesive forces. And it's logic that when you bring in your cleaning system, that your forces have to be larger than the adhesive forces. So you bring in your mechanical force, you bring your thermal force in there, in your chemical force, and the sum of these 3 forces are stronger than the adhesive forces, and that's basically how your system removes the soil from the tank wall. We have a number of parameters which influence your cleaning. So we have the equipment parameters, we have the system parameters, and the operational parameters. These 3 are the major parts which you need to observe like from the beginning on when you start building something. Let's say here, equipment parameters. This is something which you have to consider when you start building something or bringing in new equipment, or you're moving from an old to a larger facility and so on, that all the equipment is designed for an easy clean. Hygienic design is like a keyword for this, that basically you don't have any rough surfaces where, your dirt gets attached or adhesive forces are getting bigger, or the materials are chemical resistant or compatible, such things. So basically, when you start planning for your new production facility, make sure that all of the sanitation and cleaning has been part of this to ensure that later on you don't run into issues. And the more you can add as automation, the easier it is at the end, and you will save a lot of time and money. System parameters. This is then during once you have everything built up and you start now actually working, which are determined during the regular operation. So, for example, the chemical composition, the quantity you need, what's in it, how it's built. Then, of course, the frequency of sanitation, depending on what you're producing. Is it something which is not so heavy, loaded with organic substances? Maybe you can run 3-4 cycles before you clean. If it's something with a higher, maybe you have to clean it every time. So depending on your situation and the amount of material you put in, the frequency is, needs to be determined. Then also the soil load of the cleaning solution itself. Like I said before, if you have a strainer before your CIP collection tank, you should have basically the capability to reduce the soil load in your caustic, and you can use it more often, which saves you a lot of water and chemistry. I talked before that the quality of the process water itself, especially the hardness, is a big issue. And then what many people not really, put into the front is, where are you actually situated? Of course, you always have a location, you like it, you want to be there, but just isn't getting the idea, like if you go to, southern states like Florida, Georgia, or Texas, where the summer months are very hot, very humid, that has a lot of impact on your production facility, especially if it's not really completely enclosed with an air conditioning, with a air dryer and so on. So you have always a hot and humid environment inside, which of course favors easily the growth of mold and other biofilms. Whereas if you go like into the Rocky Mountains, Montana, and these areas, or Colorado, where you have a very, very dry environment, when 10% humidity is already considered as high, they don't even know what mold is. So they don't really have to battle stuff like this. So keep this in mind when you're in a hot, humid area, for example, or wherever your environment is. Even if you're close to the ocean, and there's like a high and low tide, once the bottom, the floor of the ocean gets opened up, your microbiological load is very high, and that also can have an impact on your internal system. So always make sure when you look into your location, what is the conditions around me. And then, of course, the CIP equipment. If it's a small facility where you just fill a tank through a manhole with water, you add a little bit of the caustic, then you have a pump which circulates, pulling out of the cone, pumping it up to the spray ball, up to the, fully blown automatic high-end CIP equipment. All these different parameters basically determine your daily routine life. Then Mr. Sinner, he was a guy working for Henkel Ecolab. He basically said, okay, we have 4 parameters in cleaning. We have the concentration, we have the temperature, mechanics, and time. And when you work with those, you can manipulate the mechanics is pretty much set. You can't change much there. But you can say, okay, I have a very time constraint, so I cannot, let it run for 3 hours. So maybe I have to increase the temperature or the concentration. So the pie shape will be getting better for, the red temperature or the blue concentration, but I can shorten my time. Or if you say I don't have any energy to heat it up, basically the temperature gets smaller, so I have to let it run longer, or I have to basically increase the concentration of the chemical to compensate for the lack of temperature. So with these parameters, you can actually optimize your cleaning and, to your specific needs. Mostly if I get asked, what would you recommend? I said, so what is your most pressuring parameter? Is it time? Is it, you want to be environmentally, so not much of energy. So according to these parameters, you can adjust your program. Temperature. Most chemicals work at ambient temperature. The only one where we really heat it up is caustic. Caustic has very interesting behavior at 135, 140 degree Fahrenheit, where the efficacy significantly jumps up. And there's kind of a rule out there, if you increase the temperature by 10 C, which is about 18 Fahrenheit, your chemical reaction doubles. So theoretically, you should be able to shorten or cut your time in half. Reality is a little bit different, but just from the pure chemical reaction, if you increase the temperature, they go faster, so you can shorten the system. So we always recommend caustic to be on the higher temperature, maximum 175 around. But before you really crank it up to the temperature, make sure that the equipment you're cleaning is also safe for these temperatures. Always look up on your manufacturer's, manual, what is the highest temperature, what's the highest concentration, what type of chemicals, to ensure that you don't really destroy your equipment. Time, it's another parameter. You can see, depends on the process type. From the equipment side, just the process itself, how long each step is running. And most important is, the temperature of the cleaning solution. The hotter, the shorter the time. And the higher the concentration of the chemical, the shorter the time. So if you say, I don't want to waste too much chemistry, just crank down the, concentration, let it run longer. Most of you maybe noticed that, for the last 30, 40 years, if you just look at your washer or dishwasher, from virtually 15, 20-minute cycles, nowadays they go up to 2+ hours. But they reduce the amount of water, they reduce the amount of energy because they take the time now as one of the major parameters for the cleaning. Mechanics, that's actually the most important topic, and I will talk most about this because often if there's an issue with the cleaning, it's mostly related to a mechanical issue. If you take like a classical fermenter, you have your cylindrical part, and the bottom you have your cone, and the top you have a dome. The idea is that when you have a spray ball inside, the spray ball brings the solution to the tank wall, and you want to have a closed curtain of liquid of about 2 millimeter thickness. So you have enough liquid so that you get your chemicals transported to the surface, but also that your curtain of liquid running down has enough mechanical energy to remove those loosened particles and bring them back to the CIP tank. So very important is when you see this, that you always make sure your spraying device is in perfect conditions. Otherwise, it won't work. You open up your tank after cleaning and you see one side is completely dirty. Maybe you have some blockages in your spray ball or your rotary system is not doing its job. So what I recommend, and this is only if you use cold water, no chemistry, cold water, and if you have a manhole in a smaller tank, just circulate that water and watch with a strong flashlight to see if you really have a closed curtain coming down on all sides. Sometimes some of my colleagues even used a GoPro, with a stick on it and kind of filmed it inside just to ensure that all the complete wall is covered in a nice liquid curtain. Spray balls, they come in all kinds of shapes and sizes. Smaller tanks mostly have a static spray ball. The majority use like a 360, which is the far left, because it's a much easier way to get everything cleaned. Quite often when you look at these tanks, when they get filled, the foam comes up, the CO2 rises more and more. So everything in the tank will be completely, covered in, a soil. But then you have all other ones, you have a 180 down, a 180 up, depending on your tank. If you have an open tank, maybe 180 down is sufficient. But that's basically at the end more like how you have your system set up. Very important, especially for pipes, is the flow through your pipe. And here we talk about two terminologies. One is laminary flow and the other one is turbulent flow. You can see the laminar flow is basically a very straight, direct layers of, speeds of the liquid. But towards the wall, the speed gets slower and slower. And let's say the first layer of liquid on the wall has actually the speed of 0. That means that there is actually no mechanical activity and the cleaning result is not going the right direction. So what you need to do is you have to ensure that you have a turbulent flow. And turbulent flow means you have a certain minimum speed going through your pipe, because then you have internal vortexes, which then actually create enough mechanical energy to clean your wall. For doing this, Mr. Reinhold came up with a number, the Reynolds number, and he determined that when you exceed a certain number, then you can be sure that you have a turbulent flow versus a laminar flow. So if you look at the big arrow in the bottom, up to about 2100, we have a laminar flow. Then between this, from 2100 to 4000, we have a transition phase. So it can be laminar, can be turbulent. But if you get beyond 4000, you are sure that's a turbulent flow. So how do you determine this? Basically, you can see there's an equation. You have a lot of, parameters putting in. One is basically the hydraulic diameter of your pipe. What's the ID of your pipe? It's basically a length. Then, the flow rate. Mostly, you have a pump or you have a flow meter telling you what's the flow rate going through your liquid, through your pipe. Then you have the velocity. And then you have the two different viscosity, dynamic and the kinematic viscosity. And at the end, you also have the density of the fluid. Okay, these numbers quite often are given because you always have the same, liquid. You have your 2% solution of your caustic. But the velocity can be, adjusted by a pump, flow rate, speed, and so on and on. But when you calculate this, at the end, it's a unitless number at the end because all the units are basically deleted in the equation. You will get a number, and hopefully it's above 4000. The problem is if you have a system and there's a lot of pipe diameter changes, you start with a big pipe and then further down your pipe's diameter, gets smaller and so on. You need to ensure that the speed in each diameter change also changes. So from a bigger to a smaller, that's not so bad because the same amount goes through a more narrow pipe, so the speed will increase. But the opposite, when you switch from a smaller pipe to a larger pipe diameter, then the flow will slow down. And that's quite often the area where you have then the problem that you don't get the proper speed anymore. If you really want to find out what's going on, you can rent, flow meters, which you attach to the pipe from the outside. So you don't have to build anything in. And the system can tell you exactly how fast your liquid is, what the flow rate, and so on and on. Just to give you an idea, if you have a pipe diameter of about 80 millimeters, the DN80, which is a little bit more than 3 inches, and you go up to 4 inches, which is about 100 millimeters, your speed drops from 2 meters per second to 1.25 meters per second. So that is already a questionable area. So if you have pipe diameter changes, make sure that even in the thickest pipe, you always have the proper speed to ensure a turbulent flow. Here's an example. That's exactly the same pipe, and it was cleaned and it was done purpose just for demonstration. We ran it very slowly through, so we definitely had a laminar flow. You can see now that the pipe didn't get cleaned because at the wall there was 0 mechanical activity. And then we repeated it and we speed up the liquid, so we had a turbulent flow, and you can see it's spotless, nice and clean. The chemical itself, and we talked about this already before, we deal either with organic substances or with inorganic substances. And depending on what it is, you have different types of chemicals to clean. So here's a little bit of a picture to show you. Sugar, is basically water soluble. Of course, if it gets kind of, scorched on, then it's not that easy to dissolve by water anymore. But then when you go over to fat and protein, which is considered as an organic substance, then that's when your caustic comes into play. And then if you continue on to the inorganic substances like salt and minerals, that's where acid needs to be done. Everybody knows from home, your coffee maker, your water boiler inside of your kitchen, when they start, showing like a scale, then you add, vinegar or another organic acid, citric acid, to ensure that the scale is removed. I mentioned before, the quality of the water is very important. The chemical properties, so you want to have the right pH, you want to have the right hardness in it, but also biological. You don't want to have a ton of contamination, microorganisms in there, because they will be carried inside, and once you have them in the system, it's not easy to get them 100% out. The pre-rinsing is basically to ensure that everything which is already loose, which doesn't require any of your chemical reaction to loosen up, is removed, so you reduce your soil load in your caustic, and this should be done with a few burst rinses going straight to the drain. Then the chemical cleaning is basically the most critical part. You have to make sure that everything works. A quick, easy test: once you open up a tank and you still see spots and said, what happened? If you can wipe them off easily with, a little piece of cloth, that means we were able to bring the chemicals there. They kind of broke it down, so it's kind of loose, but we did not have enough mechanical action to remove it. If it's not moving at all, it's really hard stuck on, and it's, you really have to scrape it off. That basically tells you we didn't even get the chemistry there. So that is mostly a mechanical issue. So then we have to look into why we didn't get enough liquid there, and so on and on. Last but not least, the final rinsing is important to remove the caustic or the acid, whatever has been in there, to ensure that, when you switch from caustic over to acid, you don't have too much remaining or residual caustic, neutralizing the acid, removing the efficacy of the acid. So it's always recommendable to rinse between the chemicals. A typical program, like I said, the first is a pre-rinse with ambient temperature. It's a few minutes. Sometimes we just say a few burst rinse, 3, 4, 5 times. If you have a chance to watch like the drainage to see, when the water being very, very, dirty, in quotation mark, cleans up, that basically would be an indication that nothing of the loose dirt is there anymore. Then we do the main work. Mostly it's organic substances. So we have caustic, about 2% solution. That's the only one you can see where we go higher in temperatures. And then the circulation time varies, of course, depending on the soil load, depending on all the stuff. If you want, you can actually add a booster, hydrogen peroxide-based booster, to ensure that the efficacy of the caustic is increased. Built caustics have all the, surfactants in there to reduce the viscosity, to reduce the surface tension, so it gets deeper into cracks and crevices. Once that's done, I take water to push the caustic back to your collection tank. Mostly if you have an automated system, yes, a conductivity probe, the guiding, when the caustic is still high, the Siemens value is still high from the conductivity, it will divert it directly into the tank. Once that drops, basically you would start diluting your caustic. You just go straight to your drain. And once that is done, and everything is, if you have a pH probe or you take a litmus paper just to see, are we now neutral, around 7, then you can start with your acid. Mostly the acid is very weak. We don't need much. It's just to make sure that, this little bit of inorganic soil is removed. Often we don't even recommend to do it every time, depending on your conditions, water hardness, etc. Maybe every 3, 4, 5 times of a CIP, you actually do the acid cycle. Once the acid is done, you rinse that one out too. The beauty is acid is easier to rinse than caustic. And then you start sanitizing. So in most cases, you use basically a surface sanitizer, a chemical like peracetic acid, and sanitizers can only be used once, so you cannot really collect it and reuse it as a sanitizer again. You can collect the liquid for, let's say, the pre-rinse, so you save water. But once you have used the sanitizer, you cannot use it again as a sanitizer. Very important, before you sanitize, always make sure that your surface is absolutely clean, because you cannot sanitize a dirty surface. So to have a fully successful sanitation, you have to ensure that everything else is removed. So if you have any remaining soil in there, that's a perfect place for harboring microorganisms where the sanitizer doesn't get there. So you say, oh, hey, I run everything looks good. Sanitizer did my 15-minute work on everything. Even PA works much faster, but we always recommend 10 to 15 minutes to ensure that every spot of your equipment gets actually the 30-40 seconds of PA activity. Also, the more you have in there, especially like peracetic acid, when it deals with other material, it starts breaking down. So it also loses efficacy very fast. So the cleaner your tank, or if the tank needs to be perfect clean, then it works easy. You don't really sterilize, you just sanitize in quotation marks. So you just have a log 5 reduction of your microorganisms, which is in most cases perfect. But keep in mind, if you let the tank sit, for multiple days or weeks without using it, there were enough microorganisms surviving that when they start regrowing, you need to sanitize again to ensure right before the next time you use it, to ensure that all is really killed. The beauty with beer and also in the distillery, especially with the distillation, so you're in a different step here, we have conditions where you cannot really grow any pathogenic germs, so you are very safe, especially distillery with high alcohol content, and alcohol at the end is also sanitizer, so you don't battle, any pathogenic germs like in the other food industries where it's very sensitive, and, if it's chicken or whatever it is, yeah, that's where you can really start harming people. So we are in actually fairly safe environment. Next to the chemical sanitation, we can do also the thermal sanitation, which is used in a few ways. It's not, advisable to have like a big fermenter heat sanitize, because that's a lot of energy, a lot of steam which you need. Also, the problem is that in such a large tank, the difference between hot and cold can be very extreme. So it might be, especially where you have cooling jackets, that your metal is getting really a thermal stress, and that's not advisable. Besides, the amount of steam you need is pretty expensive. Small items like, a keg cleaner, where if you have a very small closed environment, steam is very efficient. The beauty about steam is, or heat, if you take hot water, it penetrates or heats up the whole pipe, the whole valve and everything. This way, even if you have microorganisms deeper sitting in a gasket, in a crack or crevices, then the sanitizer will not get there, but the heat will get there. So heat has its advantages, but in the majority nowadays, the PA or any other chemical sanitation is the way to go. How to optimize it, cost of clean. Some of these products are not cheap, but mostly then they're very highly built, engineered. So you basically use much less of it. So the cost of clean is actually at the end your number you're looking for. So if the product is more efficient, it's shorter, it needs less energy of heating it up and so on. So you're safe. So when you want to really do your comparison, make sure that the cost of clean, what does it cost me to clean a tank? How much time does I put in? How much liquid do I have to put in? What's the temperature, energy, and so on and on. And then you have a better way of comparing just by, hey, this product cost me X amount versus this one. So that's a big difference. The cash flow, make sure that it makes sense to buy larger quantities. Some bigger facilities have like big tanks where tanker loads are shipped in. Can you tie down so much money or not? Mostly you have all the more automation, so you have less labor. Everything is fully automated for calling by conductivity. Do we have enough caustic? Do we have enough acid in our system, and so on? Of course, it will cost upfront more, but calculate the ROI on this, and then you should be in a good picture. Storage, another problem, depending, especially if you have small brewery like in a big city where storage or space in general is not available. How much do you have available? Second, what's the conditions? The chemicals should always be stored in a cool, ideally dark and dry environment, well ventilated, of course, because especially like PA or the oxidizer, the hydrogen peroxide based one, when they get too warm, they start breaking down. So you start basically destroying your actual cleaning solution. Sometimes you have limitations, depending where you're based. You cannot have more than X amount of certain chemicals on site. What's your permit? What can you do? What can you do? Especially if you look at certain chemicals, special sanitizers in regards of your wastewater. And then, of course, the extra cost for installation of equipment. Oops. Transportation, that's also nowadays a very big topic. Trucking went through the roof. Larger quantities, lower transportation costs, less. Often the truck needs to roll up. Maybe you can share deliveries with your neighboring brewery and so on. If you have a mini bulk, basically a tank which gets filled, but it's not a full tanker load, it's a smaller one. Maybe you can have a milk run, things like that. But the chemicals is the higher concentration. Cost per unit is lower. Blended engineered chemicals, you have a lower usage rate. But although the important is stability, how stable is, especially if you have, like I mentioned before, the PA or the hydrogen peroxide or the chlorinated product, they don't have a very long shelf life, and the shelf life also depends on your storage conditions. So the warmer it is, the sunlight gets in there, the likeliness that shelf life gets reduced is very high. I talked about this. Here's just a little summary. When you look at the process parameter time, the longer, the less chemicals you need, or the lower the temperatures are. If you have a higher temperature, you can speed up the process, you can shorten your cycles, and you can use less chemicals. Mechanics, make sure that you always have an eye on your pipes, the velocity. Then, of course, the spraying device, if you have a rotary jet where you really also utilize the impingement, so you add quite a bit of cleaning force through the mechanicals. And then you can add a booster like hydrogen peroxide to optimize your caustic usage. Again, the Sinner cycle, this colored cycle I showed you before. I will say, which I mentioned before already. So what's your personal preference? Make sure that you look at your own, system, you look at your own schedules and everything. What's ideally, where's your bottleneck in your process? What's available? Do you have high energy cost? Do you have low energy cost? How's the water? How's the water available? What's the price of the water? What's the quality of the water? And so on and on. What's your wastewater? Do you have to treat it by yourself? Do you can put it down the drain without any treatment, no pH adjustment, and so on? So this is something which you need to determine. We are more than happy to help you on this. But, this is something you have to figure out to see where is your personal preference of cleaning. CIP automation. That's another thing which I would like to put a little bit of an emphasis on. Nowadays you get these fully automated systems, you get these nice screens, with all these beautiful colored curves, the control units and so on and on. Problem is, are you sure it's really doing this, what it is? It's like, is your temperature gauge inside reading the right? Is your conductivity probe reading the right concentration? So if you start leaning back and relying on this, that is not the best idea. You still have to make sure every time that all the systems are reading correctly. So there are, certain PMs for, a temperature probe, a conductivity probe, and so on, where you basically just control, is this correct? And if you just, take a external thermometer, you hold it up to the pipe, or you hold it up to the liquid to see, is it the 140s, which the system tells you really. You take a sample of the probe, you measure the concentration, you measure the conductivity. Is it the same like the others? So just make sure that when you have the automation, that you also use these basically audits to make sure that all the equipment is properly working. So to control this and to validate and give yourself an overview to make sure that you don't have sleepless nights. I mentioned before that multiple parameters of a CIP work together to make sure, record everything, make sure that you have proper recording, documentation of all your cycles, so you can see either a drift, when you see, for example, that the CIP solution takes longer to heat up. Maybe your heat exchanger of your CIP system is not clean enough anymore. Or, the conductivity probe is off. You see also a higher usage rate. Maybe there's some air in the system so that your conductivity probe is reading wrong numbers in quotation marks. When you do all this, very important, when you design your CIP system, everything in advance, make sure you take everything in consideration. Ask people once you've done it, and then you need to change afterwards. You have to add something, you have to remove something, you have to redesign something. That's what gets mostly very expensive. There are so-called dye tests out. It's a liquid with an alcohol. You spray it on everything, the alcohol evaporates, and then this dye remains. And then you can actually run the system, especially like in fillers, where you have like the spraying nozzles, and just test it if the spraying nozzles are working properly, or if you see areas where spray shadows basically, stop the cleaning on certain spots. So make sure that this is done on a regular basis to ensure that all your equipment is working properly. Very important, dead legs. Many companies buying used equipment which have been altered by the previous owner, and then, mostly they don't really know why this is here and what is this for. There are certain pipes which, sometimes they're only like 10 inches long. But a dead leg is basically when the length is about 1.5 to 2 times the diameter. That's considered a dead leg. Once you have it in there, it's hard to clean. So you want to make sure that there's no dead leg on your system, because this is a perfect place for microorganisms and so on to harbor. Some simple things is puddles in vessels. Sometimes the equipment, if it's not either properly installed, perfectly leveled, or the bottom of the tank is not perfect, you might have puddles leaving, and then not only that it's a perfect area for growth of microorganisms, biofilms, but all the bathtub rings. So this is something which definitely needs to be eliminated. The pipes, again, like I said, double check with a flow meter, and the systems control that the speed through your pipes is proper to ensure that you have turbulent flow. Also important, when you have a system, a pipe, of course you always look for aesthetic reasons. Everything needs to be either vertical or horizontal. But for most pipes, it's always advisable to have like a little slope so they're self-draining, so no liquids remain standing there for days and weeks and so on, because that's areas where microorganisms can, start regrowing, and then all your cleaning and sanitation effort was basically useless. Simple things like, if you have a gasket, don't over tighten it, don't squeeze the water out of a gasket, because then you start having leakages. Replace the gaskets on regular schedules. If you have a passivation going on, maybe you should have a different gasket set for this, because mostly the very strong nitric acid is pretty harsh on gaskets. So make sure that this is perfect, because the losses, either it's a loss financially, but although if you have dripping harsh chemicals, caustic acid on the ground on something, there's either danger of people, or you damage equipment. And then, of course, always trust your senses. If you see something, report it, investigate it, that at the end of the day, you will have everything taken care of in regards of, a failing pump, a failing valve, and so on, to avoid any problems. When I say trust your sense, you always do your quality checks with your product. You do a sampling, you taste it, you look for flavors, you look for, it's a typical flavor, whatever your product have. But we have multiple senses. We can hear things, we can feel things, we can see things. So if you see all of a sudden, you can smell things. You smell like you walk in, all of a sudden it smells a little bit like burnt rubber. Maybe a gasket is running high and dry and high temperature. Or if something is out of balance, you feel a vibration of a centrifuge, things like that. So make sure that when you have all your equipment running and they're running as they're supposed to be, you get a certain picture. And then at the end, If something is off, you can easily identify it, and then of course make sure that it's get taken care of before the damage or whatever gets bigger and bigger. So this is a little video you can see now. This is done on purpose. There's basically the danger of, in the beverage industry. There are multiple reasons for this. One is actually that if you have still a lot of CO2 in it and you start with a caustic and you haven't really pre-evacuated the tank, the CO2 is nothing else like an acid. It will neutralize with the caustic, and basically the gas is gone, so you have zero pressure in your tank, and then you will collapse it. Another possibility is if you have a very, you run a hot caustic cycle, everything is very hot, and then you come in with a very, very cold water and you suddenly drop significantly the temperature from warm to cold. That also means you have a significant pressure drop. That can also the reason for a collapsing tank. And even if you have a pump pulling out, your product for the next process step and so on, and you don't vent the tank properly, it can happen that you can actually also pull a vacuum by pulling out the liquid. So thank you so much. And now I would like to open the floor for any comments. Please type it in. I think we still have a few minutes left before we are done. So let me know if you have any questions. No one any comments? No one any questions? So if nobody's there, then I would say thank you so much for your attention. And then whenever you have another time, just reach out to me. You see my email address and everything. And if you have questions, don't hesitate to ask me. Thank you and have a nice day. Bye-bye.